coral, which had previously been thought to be a plant, was in fact an animal. Herschel made a huge leap of imagination. If this approach with light and lenses worked for things on Earth, maybe it would also work for the heavens. Herschel would treat the stars the way living species are treated. He decided to classify them.
But what you needed to do that, Herschel reckoned, was huge telescopes, which by penetrating deeply into space would be able to classify what kinds of things stars, nebulae, and galaxies really were. He would become the first natural historian of the heavens.
But there was a problem with building huge telescopes. Since Galileo's spyglass, people had built longer and longer telescopes, which proved almost impossible to manage and possessed lenses which could never bring the image into perfect focus. Herschel had a different idea. He realized he could apply one of Newton's cleverest ideas and replace lenses with mirrors. A curved mirror magnifies rather the way a lens does. But most importantly, mirrors grasp much more starlight than any comparable lens. Trouble was, no one had ever made mirrors this big before. They would have to be curved with exquisite precision to focus the light. So Herschel took matters into his own hands. He turned his kitchen into a factory to make mirrors and would spend up to 16 hours a day painstakingly polishing them to get them to just the right curved shape to focus the light. He was obsessive about this and became the world's best maker of mirrors. Once he'd perfected his mirrors, he put them to use inside his telescopes. Herschel dreamt up a cunning scheme to allow you to see the mirror's image. Light entering the telescope would reflect off the big curved mirror onto a smaller mirror set at an angle. Looking into this second mirror allowed you to see the brightly illuminated image without blocking it.
With his new telescope, Herschel soon made an amazing discovery. On the 13th of March, 1781, he saw what he thought at first was a new comet. But very soon it emerged it was a new planet, the first ever discovered in recorded history. As an attempt to get patronage out of King George III, Herschel and his friends decided to name this object George's Star, but no one else decided to call it that, so it's known to us as Uranus. It was an extraordinary triumph for Herschel's astronomy.
Simply by finding this planet, Herschel had doubled the size of the known universe. King George rewarded Herschel with a life pension and a house in Slough, making him by far the most successful amateur astronomer in history. But Herschel's next discoveries would be even greater, even grander, and they'd hinge upon a fundamental property of light, its speed.
The question of whether light takes any time at all to travel was an ancient one. It had been discussed by the Greeks. But it's a major puzzle. It doesn't seem at all obvious that light does take any time to travel. When I look at some really distant object like that tree, To look at it is to see it as though light is instantly switched from there to here, from the object to my eye. So that was a fascinating and really urgent puzzle. Was there a way of working out whether light does take any time to travel? You couldn't hold it in your hand and measure its speed.
The answer lay in the motions of the solar system, and in particular, the motions of the moons round Jupiter, just those moons that Galileo had first observed with his telescope. Now, in 1676, a brilliant young Danish astronomer here on Earth, Ole Rømer, was observing the moons of Jupiter because he wanted to measure the times they took to go round their planet. And he spotted something very surprising. The time he was measuring depended on the distance between the Earth and Jupiter. When the Earth, as it orbits, was nearer Jupiter, he seemed to be seeing the moon going round Jupiter rather quickly. And when it was further away, he seemed to see the moon going round Jupiter rather more slowly. And Rømer could explain the difference. It was due to the time it takes for light to travel from Jupiter to the Earth. Light does take time to travel, and you can measure its speed.
Rømer calculated a figure and got astonishingly close to the real speed of 300,000 kilometers a second.
The realization that light actually does take time to travel and the exact measurement of the speed of light were the most amazing discoveries. It was a building block for an entirely new kind of physics. William Herschel was cunning enough and intelligent enough to realize just what the finite speed of light meant for him and his work. When you look at the sun, you're not seeing the sun as it is now, but as it was about 8 minutes ago, because it takes light about